Okay, so you've been dipping your toes into the cloud world. Maybe you're working with AWS,
Mm.
something like that. And now you're thinking, okay, how do these things actually work, under the hood? You're curious about maybe building your own private cloud at home, a lab, a place to experiment, learn the nuts and bolts
Yeah.
without, racking up a huge public cloud bill. And that's probably led you to look at OpenStack.
Yeah, OpenStack, it's really the definitive open source platform if you want to simulate a real cloud environment. It gives you all those core services you see in public clouds compute, VMs, networking, storage, block, and object. Building an OpenStack lab, it's basically like giving yourself the blueprints and the bricks to build your own little mini cloud right
Yeah.
there on your own gear.
It really is the gold standard for like understand cloud architecture from the
Right.
ground up. But here's the flip side, right? And this is the big challenge our sources really focused on.
Yeah.
OpenStack has this reputation. It's seen as, well, complicated,
Yeah.
maybe really complicated,
Yeah.
and potentially really expensive too. So for someone just wanting to learn at home, you immediately hit these questions. Do I need like multiple servers, big enterprise hardware? How do I even start without accidentally building, a money pit in my spare room?
Yeah, that complexity and the perceived cost.
Right.
Uh, there are significant hurdles, no doubt. But what's fascinating about the sources we looked at is how they tackle this, like head on. They draw a lot on community experience, people who've actually figured out how to get started, learn the ropes,
Yeah.
and build functional OpenStack labs without needing a massive budget or, a dedicated server room.
Okay, so that's our mission for this deep dive then. Let's unpack those practical kind of hard-won strategies from the sources. How do you actually get your hands dirty with OpenStack, understand its guts, gain real skills, but without spending a fortune? Let's dig in.
So the first question the sources sort of answer implicitly is, given that steep learning curve, why even bother with OpenStack for a home lab?
Right.
And the consensus seems pretty clear. It's complexity. Well, that's precisely its value for learning.
That sounds a little counterintuitive, doesn't it? Like the pain is the point.
Or,
Uh,
well, in a way, yeah, you gain this unparalleled understanding of how distributed cloud systems really work. When you're wrestling with neutron networking or troubleshooting Cinder storage, you're grappling with the fundamental concepts: resource allocation, service interaction, in a way you just don't when you're clicking buttons in a public cloud console or using some simplified tool. It's modular by design, so you really see how Nova, Neutron, Keystone for identity, Glance for images, Cinder for storage, how they all fit together.
and the sources mention that because it is so complex, things will go wrong. Like that's just part of the deal.
Oh, absolutely. The sources are very realistic about this. Errors, they're part of learning OpenStack. Guaranteed. And because of that, they strongly, strongly caution against starting with a setup that's hard to fix or reset. If every little mistake means hours of troubleshooting or reinstalling an OS, you're just going to get discouraged super fast.
Okay, so acknowledging the complexity and knowing you will mess things up. That leads us straight to the first, maybe the most critical piece of advice from these sources for starting affordably.
Yeah.
And that is embrace virtualization.
This is basically non-negotiable for a budget home lab, according to all the community wisdom in the sources. Forget trying to scrape together multiple physical servers right at the start. No. Run OpenStack inside virtual machines. On a single, reasonably capable physical machine. That's the recommended starting point.
Okay, why? Why is virtualization such a game changer specifically for learning OpenStack at home?
It's all about agility and recovery. Speed of recovery. With VMs, your whole environment, the OS, the OpenStack services you installed, all the configs, it's just a file. Or, a set of files. If you break something really badly, often you can just revert to a snapshot you took like minutes before. Or worst case, just delete the VM and spin up a fresh one.
Compared to what? Like reinstalling Linux from scratch on a bare metal server.
Exactly. Imagine spending hours installing Linux on, say, 3 physical boxes, setting up their networking. Then you try an OpenStack deployment and it fails because of one tiny typo in a config file. Recovering from that on bare metal, that can be a huge time sink. Days, maybe? With VMs, that same failure might just mean rolling back a snapshot, fixing the typo, and trying the deployment again in like 10 minutes. That rapid iteration, it's absolutely essential for learning OpenStack's quirks without getting bogged down in slow, painful recovery.
Okay, so let's get practical then. Within this virtualization approach, what's the absolute simplest way to begin? The sources had a clear favorite here.
Yeah, the top advice is start with a single node VM setup. Don't even think about a multi-controller, multi-compute cluster at first. Just get one VM, run it on your laptop, maybe a decent desktop or a basic server you have lying around, and install all the core OpenStack services onto that single VM.
Wait, one VM running everything. Nova, Neutron, Cinder, Keystone, Horizon Dashboard, all sharing the same virtual CPU and RAM. What does that even look like, hardware-wise? Do I need a beast?
Actually, no. For this single node learning setup, the sources suggest you don't need enterprise gear at all. A decent desktop, maybe a basic tower server from the last, say, 5-7 years. That often does the trick. The key resource you need is RAM. Lots of RAM. They recommend aiming for 16 GB minimum, but ideally 32 GB or even more. Because you're running a lot of services, right? A reasonably modern multi-core CPU helps too, sure, but RAM is usually the main bottleneck for getting all those components running together for testing.
Okay, so I get this one VM setup. If you give it 32 GB of RAM, install OpenStack. What's the learning benefit of cramming everything onto one node like that? Seems counterintuitive again.
It massively simplifies the initial hurdles, especially networking and inter-service communication. You immediately see, okay, Nova needs to talk to Keystone for authentication, or Cinder needs to talk to Nova. You learn those fundamental dependencies without having to troubleshoot complex network routing between separate VMs or physical boxes right away. It's kind of a contained little universe to grasp the core concepts first.
And crucially, for that rapid iteration thing you mentioned,
Yes, this is where it really shines. The sources talk a lot about using deployment tools. Things like Kala Ansible or OpenStack Ansible. These tools can automate the whole OpenStack install and configuration onto that single VM for you. So if your deployment blows up or you just want to try a different setting, you can often just destroy that VM and redeploy a fresh instance using the automation tools in like under 30 minutes, that quick cycle. Invaluable for trying stuff out and seeing what happens immediately.
okay, that leads really nicely into sort of doubling down on this virtualization idea. The sources really emphasize that running OpenStack inside VMs isn't just a starting point, it's a perfectly valid, budget-friendly way to simulate even more complex stuff.
Exactly right. Once you've kind of mastered that single node VM, you can then use your hypervisor, maybe Proxmox, VMware Workstation, ESXsec has free tiers, even VirtualBox to create multiple VMs on that same physical machine. So you can simulate a proper multi-node OpenStack cluster, separate VMs for controllers, compute nodes, storage nodes, all running on your one physical box.
So I don't need 3 separate physical computers just to test out a multi-node setup.
Absolutely not. And this is where the huge cost savings come in. It's massive. Instead of needing, 3 servers plus switches and cables just to simulate something production-like, you can often do it all with one capable machine running several VMs.
But okay, wouldn't running a whole cluster inside VMs be really slow? What about performance? Is it usable?
That's a really common concern, and the sources definitely address it. They point out that with modern CPUs, enough RAM, the overhead from nested virtualization, VMs inside a hypervisor, it's actually pretty low. Often just a small percentage hit on performance, maybe 5-8% they mentioned. For a learning or testing lab, that's completely fine. You're not hosting a real production workload for thousands of users, right? You're practicing installs, configs, basic operations. That slight performance hit is, well, negligible compared to the flexibility and the cost saving.
And those VM snapshots we talked about earlier, they become even more vital when you're building a multi-node virtual cluster, I bet.
Oh, absolutely. Total lifesaver. If you're trying to set up networking between your virtual controller and virtual compute nodes, and you mess up the VLANs or the routing, being able to just roll back all the affected VMs simultaneously to a known good state, it's your undo button for big infrastructure changes. Essential.
Okay, so VMs for flexibility, cost saving. Single node first, then multi-node simulation using VMs. Got it. What's the next layer of tech the sources recommend we leverage?
Containers. Containers are your friend here. The OpenStack community has really embraced containerization, especially through projects like Kala Ansible, which we mentioned. So instead of installing OpenStack services like directly onto the VM's operating system, the deployment tools package each service, Nova API, Neutron Server, Cinder Volume Service, whatever, into its own Docker container.
Right, and what's the advantage of using containers over just installing the services directly inside the VMs?
This is a really significant advantage, especially for learning and troubleshooting. Containers are way lighter weight than full VMs. They start and stop almost instantly. So if your Neutron service config is messed up, you can often just restart that single Neutron container without touching other services, without rebooting the whole VM. That isolation makes debugging so much cleaner. You're dealing with just one package service instance at a time.
And less resource hungry than running full VMs for each service, I guess.
Correct. You'll still typically run these containers inside your learning VMs, at least initially. But yeah, they consume fewer resources than traditional service installs would. Plus, using containers actually aligns your learning with modern cloud-native deployment practices, which is a nice added bonus. Oh, and it makes testing different versions or upgrades of just one service much easier, too, in isolation.
Okay, so we've got start simple with VMs, scale up simulations using VMs, deploy services with containers for easier management and debugging. Makes sense. What happens when you feel like, okay, I've kind of outgrown the purely virtual world, or maybe you, I don't know, acquire some older physical hardware?
Right. That's where a pretty clever community trick comes into play. The sources called it something like go hybrid when you're ready. You don't have to jump straight from a fully virtual lab to a fully bare metal one. You can mix and match.
Interesting. How would that work, practically speaking?
Well, a common hybrid approach is keeping the OpenStack control plane services running as VMs. So the APIs, the database, the message queue, Keystone, those critical config-sensitive parts stay virtualized. You keep those VM advantages snapshots, easy management for the brains of the operation. But then you can connect actual bare metal servers you might have to your OpenStack environment and use them as your Nova compute nodes, or maybe Cinder storage nodes.
Ah, I see. So the brains stay safe and manageable in VMs, but the muscle for actually running workloads or storing data can move to bare metal for maybe better performance.
Precisely that. This lets you reuse existing gear. You might have an old desktop, a server someone was throwing out. You scale gradually, adding physical nodes only where they give you the most bang for your buck, like compute power or storage space. It gives you that flexibility and ease of management from VMs where you need it most, and the raw power of bare metal where that's more important.
And I guess this hybrid approach also gets you closer to understanding how real-world OpenStack deployments often work, right? They're frequently a mix of virtual control planes and physical compute storage.
Absolutely. It forces you to learn about integrating physical hardware into your cloud fabric. Dealing with network booting, drivers, hardware quirks. That's a crucial skill if you're serious about infrastructure management.
Okay, great. So we've covered the technical path. Start simple, virtualize like crazy, use containers, go hybrid eventually. But building a lab also involves learning the concepts, right? And official training can be super expensive. How do the sources suggest we tackle the knowledge part without breaking the bank?
Yeah, this is maybe the biggest cost-saving area. Use the free stuff. Seriously.
Yeah.
The OpenStack community is just vast and incredibly active. They've produced a ton of high-quality free learning material. You absolutely positively do not need to pay for expensive courses or certifications just to get started and build a really solid foundation.
Okay, like what kind of free resources are we talking about specifically?
The absolute cornerstone, highlighted everywhere in the sources, is the official OpenStack documentation. It's comprehensive, covers everything from the high-level architecture down to installation steps and API references. It can be a bit dense, sure, but it's the authoritative source. You have to get comfortable with it. Beyond that, focus on the docs for those deployment tools we mentioned. Kala Ansible, OpenStack Ansible, even OpenStack Helm if you go that route. Their guides often walk you through setting up a single node or a simple multi-node lab, like step by step.
So official docs for the what, and deployment tool guides for the practical how-to on a budget.
Exactly. And definitely don't underestimate community blogs and forums. Seriously valuable. The sources specifically mentioned people like William Purdue who share super detailed guides, troubleshooting tips, all based on their own home lab adventures. These personal accounts often fill in the gaps the official docs might leave, giving you that practical, real-world advice. And just searching forums for specific error messages you hit, that's standard practice and totally free.
Are there even free distributions of OpenStack itself available?
Yep, there are. Canonical's Charmed OpenStack got a mention as one option. It uses Juju charms, which might be an easier deployment path for some. Exploring these different free distributions can actually be part of the learning process itself. When you put all these free resources together, docs, guides, blogs, forums, distributions, you basically have a complete learning ecosystem. And hey, that money you save on courses, that can go towards that 32 GB RAM upgrade or just paying the electricity bill for your lab.
So pulling all this together then, the core message from the sources feels incredibly, well, empowering actually. Building a functional, affordable OpenStack home lab. It's totally achievable. It's less about having shiny, cutting-edge hardware and much more about smart strategy, leveraging tech you probably already have access to, like virtualization and containers. And most importantly, tapping into that huge wealth of free community knowledge and tools out there.
Right. It really shifts the focus. It's less about capital spending and more about intellectual investment and just smart resource use. This whole approach makes learning something as potentially daunting as OpenStack much more accessible to way more people.
And the big takeaway, the sort of overarching theme, seems to be that success here comes from learning by doing.
Hmm.
But it's enabled by these specific techniques: virtualization, containers, starting small, that make experimenting cheap and recovering from mistakes easy. Start simple, single VM, use containers for agility, maybe go hybrid later, and constantly lean on the free docs and community help. That seems to be the path.
And that journey, starting with minimal hardware but maximum strategic thinking, it builds hands-on skills that are directly transferable to the wider cloud industry. Doesn't matter if you end up working with OpenStack in production, managing other private clouds, or even just wanting a deeper understanding of how public clouds like AWS are built underneath.
Yeah, and the sources kind of leave us with this really motivating final thought, don't they? Something like, and who knows, today's experiment might be tomorrow's production-grade cluster. It really makes you think how these foundational steps, taken affordably in your own home lab, could be the start of something much bigger for your skills and career.
Absolutely. What's really fascinating here, I think, is how starting small and virtualized builds that foundational understanding of these incredibly complex systems. It kind of raises an interesting question, doesn't it? Does the enforced simplicity and the need for really rapid iteration that you get in a resource-constrained home lab, does that actually lead to a deeper, more practical grasp of cloud architecture compared to, say, learning it in a massive pre-built enterprise environment where everything just works?
That's a great point to chew on. It certainly feels like maybe the struggle in the small prepares you better for the challenges when things get big. Well, thanks for digging into all these strategies for building an affordable OpenStack lab without losing your shirt.